we chose that fourth degree function, a sixth degree function that we graphed. Any questions? In 3.3, we look at division of polynomials. Do we need to look at another synthetic division or long division, or are we okay with those? We're okay with those. Then in the next section is 3.5, and we can, if you want, we can look at another rational function to graph, type 1 or type 2, if that's what you want. Let me know if that's what you want. And in section 3.6, we can go back if you remember anything. And in section 3.6, we learn how to solve polynomial and rational inequalities. And this way, I think it was one of the problems we started with today, which is this. Okay, can I make up some problems then? We still have about 25 minutes, 30 minutes. Yes? Okay. My previous class had some interesting questions. This is what I did with them today. Okay, so they asked a question like this. They said, how do I solve this inequality? This is a little bit more sophisticated because I have to move 2 to the other side, find the least common denominator, combine like terms like we did, and then, right? We didn't really have an example like this. All our examples were really all factored. We were already given them in the factored form. We didn't have to perform all these steps to get to a ratio. So we can do a problem like that if you'd like. Then we looked, of course, at the same problem. I'm just showing you, and then we'll choose. We did the same type of problem. This was another example in which this could not be factored at all. So we had to find the x-intercepts using the Corati formula. We had to put them in a table, and we had to choose a number to the left of this number, a number in between these two, and the number to the right to figure out the sign. So that was another example. I think they came across something in my math lab. Again, they picked another problem from the book, which was this. Same idea. We had to move everything, and a lot of work, a lot of prep work, till I get it to be factored in the factored form. So I can use the table. That was another question. Then they said, show us another one with a hole, a rational function. Yes, I showed another factor function with a hole. So the factor that stays is a vertical asymptote. The factor that goes away at 1 is a hole. And we graphed it. And then we looked at function composition with 2 functions. Then they said, okay, show us another function like this in which we have to determine the domain. And then we looked at another long division and synthetic division with the same problem, and another function decomposition. So this is what they asked during class today. So what appeals to you? And then I'll choose problems. Is there any particular problem that you would say, well, I think I would like to see another one? Of any type. If not, I will pick. Okay, I'm going to pick from the end of the chapter. Okay, so let's look at, for example, do we need another inequality? Yes? Okay, very good. So let's look at 73 on page 459, and we have x plus 1. x minus 2 over x minus 1 greater than or equal to 0. So please copy this problem and work on it, and I'll find other problems. And we'll work on it together. To solve. And then I would like us to graph 57 on page 458. Do not copy the second one. We're going to work on the first one, and then we'll work on the second one. So let's graph that. And then I would like to look at a division on page 457. 10x to the third minus 26x squared plus 17x minus 13 divided by 5x minus 3. So that's it for now, and then we'll see. Do we need more time for the first one? Ready to work on the first one with me or not yet? We need more time? I'll wait. Do we need more time on the first one? I see 3 factors. All those factors have to be in the table, one at a time. I have to establish and find, if you want, the zeros for each factor. When is the first factor 0? When x is -1. When is the second factor 0? When x is? When is the third factor 0? When x is 1. So I wrote them on the side just to make sure that I put them in the table in the correct order. So the first one will be, and then, very good, awesome. There is a 0 for x plus 1. Under, there is a 0 for x minus 2. And there is a 0 under for x minus 1, which is under 1. Now I have to write the corresponding values or non-values, whatever. I have to write something for the product or ratio under each of these. What do I write under -1? Yes, because this factor at the top is 0. What do I write under 1? Yes, because this factor in the denominator is 0 now. And what do I write under 2? Very good. Now, there is no difficulty in this case because all of them have the same slope. So they all come from negative and go to positive. If you have any doubts, pick a number. But where do you pick a number? Between negative infinity and it's 0. For this one, between negative infinity and it's 0. And for this one, between negative infinity and it's 0. And then on the other side of 0. But there is no need because we know they are all the same. On the first subinterval, I multiply or divide 3 negatives. Then 2 negatives. And then positive. Only now I'm asking myself, what do I want to pick? Well, it's clear that I have to pick positive because that's positive is greater than or equal to 0. So I look at the bottom of the chart. I see that this expression is positive here and here, but I actually have to pick the values of x that make that happen, make that possible. So that's why I write x in the interval, -1, 1, because I have the equal symbol, but I will never be able to or allowed to put a bracket at 1 because of this. And then union 2 with a bracket and infinity. So what does this say? If I pick x here or here, this whole thing is guaranteed to be positive. If I pick x here or here, this whole thing will be less than or equal to 0. Okay, so let's graph this function. F of x equals 2x over x squared minus 9. I'll let you work on it for a couple of minutes, but what will you do first? Remember, the preparation is very important. I will identify the type. What type is it? Type, it's rational, and out of those 3, which one? Look at the degree top and bottom before you identify it. The degree of the top is, the degree of the bottom is, so it cannot be type 1. Obviously, it's not going to be type 3, but it's definitely, which I know the horizontal asymptote is right away. What? 0. Type 2 always has horizontal asymptote 0. Why? Because at infinity, this will be so powerful in comparison to this. This will be small. This will be very big because it's infinity squared. So that's why the horizontal asymptote for type 2 is always 0. Okay, so what will, after that, what will you do? So you'll write y equals 0, horizontal asymptote, so I don't forget. But the prep is very important. What prep am I talking about? What can I do to this function right away? And I should. Without which I cannot even find the domain. Factor the denominator. So 2x divided by, I will have to do that even before I do anything else, before I find the domain, right? Without factoring the denominator, I won't be able to find the domain. So how do I factor the denominator? This is absolutely mandatory. So then I can get my chart going. So what is the domain of this function? Except those quantities, though, yes, because they make the denominator 0, and I know that's a no-no. So negative infinity, -3, 0 has to be in the table, 3 and infinity, and I have to do this under 3 and -3. These two factors don't go away, so then x equals -3 and x equals 3 must be definitely not wholes, but Absolutely. 0, 0, as we discussed. Y equals 0 is the horizontal asymptote. When x is 0, 0 at the top and negative 9 at the bottom, 0 over negative 9 is 0. Once I write VAs, I know that this must happen. It's mandatory. Otherwise, they will not be VA. So they must be infinities, but what I don't know is the sign. So I will use something like negative 3.1 and negative 2.9, and I will use 2.9 and 3.1.
Why are you using decimals?
Very good. Very good question. So the vertical asymptote is negative 3. If I test at negative 3, if I test at negative 4, it may be too far out. This, what the function value is here, may not tell me where the function is going next to the asymptote. I have to be as close as possible to the asymptote. If the asymptote is negative 3, then I have to test with negative 3.1 and negative 2.9. Anything else could be too far away and may give me a sign that is incorrect.
Okay.
Very good question. Thank you. Okay, with negative 3.1, the top is negative. This is negative. This is negative. So 2 times negative 3.1 is negative. Negative 3.1 minus 3 is negative. Negative 3.1 plus 3 is negative. 3 negatives. With negative 2.9, negative, still negative, but negative 2.9 plus 3 is positive. 2 negatives. With 2.9, positive at the top, positive, but negative. 1 negative. With 3.1, positive, positive, and also positive. No negatives. Yes, the function is odd. I will always look into it when I see symmetric asymptotes. If I replace x by negative x, this will be negative and this will not change. So the function will be odd. So let's give it a shot and graph it. When I graph a function with asymptotes, what is my responsibility to do first or graph first? Always the asymptotes. So the y equals 0, I would not bother with it. This is an overkill. There is no need, but you can do that. That's fine. Negative 3 and positive 3. I have to graph x equals negative 3 and x equals 3. These are not part of the graph, but they have to be graphed first. Now I read, and I'm only looking at the y values. 0 dropping to negative infinity. From 0 dropping to negative infinity. That's the first piece. From approaching 0, the horizontal asymptote, down to negative infinity. Now in the middle, from positive infinity, crossing normally at 0, because there is only one solution, and coming to negative infinity. From positive infinity, crossing at 0, 0, going to negative infinity. Is this clear, the middle part? And what about the last part? On the right-hand side of the asymptote, from positive infinity, dropping to 0. So this is the function f of x equals 2x over x squared minus 9. Of course, you should always check with the graphing calculator, just to make sure after you graph it, just to make sure that there is no error. So you should always put in the graphing calculator. Always remember the rational function in the graphing calculator has to have parentheses around the top, parentheses around the bottom. Otherwise, the calculator will calculate something else. Okay. Let's take a look at this. Can I use synthetic division for this? I could only if I factor out a 5. the leading coefficient has to be 1. So if I factor out, then the box will be 3/5. So we will say for now it's possible, but we only did simple examples with the leading coefficient 1. So this problem is asking us to use long division. Can I use long division? Yes. Is there a missing term from the top? Are they both in descending order?
Yes.
Good. If they're not in descending order, I have to rearrange them. If there is a missing term, I have to leave room. Good. So let's start the algorithm. And here it is. 10x cubed minus 26x squared plus 17x minus 13 over 5x minus 3. Okay. So my first question is, and you can write it on the side if it helps you, 5x multiplied by what will equal 10x cubed? 5x multiplied by what will equal 10x cubed? Very good, 2x squared. Remember now we have to distribute, go back and distribute to both. Change the sign. And now I did talk to my other class and they said, what if I do what the book does? I am fine with what the book does. But just be very careful. Here's what the book does. They say x squared times x is x cubed. They don't change the sign, but they all of a sudden get 0. But they do write right here in the little corner a minus with a circle, saying that they changed the sign, and then x cubed plus x cubed is all of a sudden 0, but actually they changed the sign. I don't have anything against this method. I think it's easier if you change the sign and you perform the operations you see. Not see adding, but actually you're subtracting. But it's a legitimate method. It's a good method. It's up to you if you want to do it, if you want to use it. I'm fine. Okay, so 2x squared times 5x will be positive 10x cubed, but because we subtract, I'm going to write the opposite. Then 2x squared times negative 3 is negative 6x squared, but I'm going to write positive 6x squared under like term. Then I know that these two go away. I perform the operations I see, which gives us negative 20x squared, this operation, and plus 17x. Now I'm asking myself 5x times what quantity is negative 20x squared? Negative 4x. Awesome. Remember, we do not lie at the top. 5x times negative 4x is indeed negative 20x squared. And now when I distribute, I will change the sign because I have to subtract. Negative 4x times 5x is negative 20x squared, but I write the opposite. Negative 4x times negative 3 is positive 12x, but I have to write the opposite. Perform the operations I see, and then negative 13. This is definitely the final question. How do I know it's the final question? Here's how I know. Because these two degrees are the same. This will be the final answer, final question. Plus exactly. Awesome. 5x times 1 is 5x. So 1 times 5x is 5x, but I have to change the sign. 1 times negative 3 is negative 3, but I have to change the sign. These two go away. What do I write in the box? Perfect. Here's a question now. Is 5x minus 3 a factor of all this? Why? Because there is a remainder. Awesome. Well done. So then when I write the final answer, I have then 10x cubed minus 26x squared plus 17x minus 13 divided by 5x minus 3. I write the quotient first. 2x squared minus 4x plus 1 minus, because the remainder is 10, 10 divided by 5x minus 3. Any questions on this? Any questions?
Yeah, I got lost somewhere along the way. Where did the positive 6 come from, or the negative 26?
Yes. So we determined that this first question, 5x times what is 10x cubed, is 2x squared.
Right.
Then 2x squared has to be distributed to both terms. 2x squared times 5x is 10x cubed, and I write negative 10x cubed. 2x squared times negative 3 is negative 6x squared, but I have to write positive 6x squared under like term with x squared.
Okay.
Better?
Second part, yeah.
Then this is gone, and then negative 26 plus 6 will give us negative 20x squared, and I bring down the next in line. Now the question is 5x times what is this? And it's negative 4x. Negative 4x times 5x is negative 20x squared. I write positive. Negative 4x times negative 3 is positive 12x, but I have to write negative. And then 5x and negative 13, and so on and so forth. Now here's the question. Let's say I have doubts about my answer, and I don't want to lose points. I want to check my answer. How will I do it? I don't need anyone to tell me whether I'm correct or not. So the same thing with when I say 10 divided by 3 is 3 integers plus 1/3. 3 times 3 is 9 plus 1 is 10. This is exactly what I'm going to do. I'm going to multiply this quantity by this quantity and subtract 10. If I don't get this, this is wrong. So 2x squared minus 4x plus 1 multiplied by 5x minus 3, and then minus 10. This times this minus 10. If I perform these calculations and I get this, I know that this is correct. If I don't get this at the top, I know, oops, there is an error somewhere. So if you have time, and you will have plenty of time on the test, I'll stay till you finish. So on Thursday, so there is no problem. So 5x times 2x squared is 10x cubed. 5x times negative 4x is negative 20x squared. 5x times 1 is positive 5x. Negative 3 times 2x squared is minus 6x squared. Negative 3 times negative 4x is positive 12x. Negative 3 times 1 is negative 3, and I copy negative 10. And now this is the moment of truth. 10x cubed? Yes. Negative 26x squared? Yes. Positive 17x? Yes. Negative 13? Yes. So obviously this is the correct quotient, and this is negative 10 is the correct remainder. All we did was just verify. Any other type of problem that you can think of? Okay, so 2 problems, and then I'll stop. I promise they're quick. In exercises 66 and 67, or exercises 66 and 67, involve rational functions that model the given situations. In each case, find the horizontal asymptote as x approaches infinity, and then describe what this means in practical terms. So here's f of x, 150x plus 120 over 0.05x plus 1. What is the horizontal asymptote, and what type of function is this? Okay, it's not clear. Let me copy the function. So f of x, 150x plus 120 over 0.05x plus 1. So this is 66 and 67 on 458. What type is it, and what will be the horizontal asymptote? Yes, it is rational. And type? 1, 2, or 3? Type, very good. So then y will be the leading coefficient over the leading coefficient. So 150 divided 0.05. I multiply top and bottom. I'm allowed to by 100. So this is 3,000. And was asking us to, it's a number of fish f of x after x months in a lake that was stocked with 120. So as x approaches infinity, we cannot really say that time approaches infinity, but let's say as x approaches infinity, the number of fish in the lake or the pond, whatever it is, will approach eventually the horizontal asymptote. That's what the functions do eventually. So how much? So we initially started with 120, and eventually, as time goes by indefinitely, let's say, the number of fish will increase to 3,000. Exactly. That's what the meaning of the horizontal asymptote. And the last one, 67, we have a different function. P of x, 72,900 divided by 100x squared plus 729. It gives the percentage of people in the US with X years of education who are unemployed. It is obviously what type of function? Rational, type 1, 2, or 3. Which means eventually, as time increases without bound if you want, the percentage of people with little or no education, if the model is correct, will reach what percentage? Eventually. What will be the horizontal asymptote? That is the percentage eventually. 0. It's type 2. The horizontal asymptote is 0.